Hi, I'm Andreas Glad and this is Houdini for Games. Today we're gonna take a look at creating an awesome paint splash using vertex texture animation, as well as creating a fancy decal to go with it. If you're making effects for games today, this is one of the tools you need to have in your tool belt. It is a big one, so if you're only interested in specific parts of the workflow, follow the timecodes in the description. A quick heads up before we get started, I will be using some of the newer functionalities from the game development tool shelf, so make sure that you have at least version 1.10, the development branch, or newer, and you'll be good to follow along. Alright, let's get going with this. We're gonna use a flip simulation to create the actual splash, and the first part of that is creating a source. So let's drop down a new GeoNode and call it source. Let's dive inside and get rid of the file, and let's bring in a sphere to start off. And we're gonna need this to be a polygon sphere with quite a bit of geometry so we can distort it. So let's set the frequency to like 6. And let's also reduce the size a bit so the flip simulation isn't huge and takes forever. Cool, so let's noise this up a bit, and the easiest way to do that is by using a mountain top. So let's drop one in right now. We're not looking for any specific shapes. This is just gonna be a glob of paint. But we can make it look a bit more interesting by doubling the height of the mountain top. And that's cool, but that's super spiky. So let's reduce the roughness a bit, maybe remove it completely. Yeah, so that could be a glob of paint or blood or whatever goopy stuff you were trying to do. The shape is cool enough to at least use as a starting point for a flip simulation. So let's drop down a null and give it a name that we can find in the dot network later, something like source. Now before we start simulating, there is one more thing that would be good to bring out of this geometry. And that's some initial velocity that we can use to start off the actual simulation. And there's a quick and dirty way of doing this, and that's by just using the normals of the mesh as the velocity. So let's set that up right now. So drop in a normal node and make sure that it's set to add normals to the points. That way we actually have some normals to turn into velocity. And as you can see when you're previewing the normals, they have some interesting patterns going on. So it's gonna give us a good noisy start to our simulation. Now, to turn this into a velocity that the dot network can actually use, let's drop down a fluid source node. And then we're going to go ahead and ignore most of the settings on this node as they're not relevant to what we're doing. What we do want to check out though is the velocity volumes tab. Because here you can specify a source attribute that it's going to use to generate the velocity field. And we're just going to go ahead and tell it to use the normals, so type in n. And now you can see a preview of the velocity field that it's generating, and it has that cool noisy feeling that we had in our normals. Now, on the fluid source node, you could add some curl noise and some vortices to make your simulation look more interesting, but I'm gonna leave all of that experimentation to you. And instead go ahead and drop down a null, which I will call vel. And that's it for our source. Now we can move on and actually start simulating. And to do that, we're gonna go to the Particle Fluids tab and click Flip Fluid from Object. We're gonna select our source and hit Enter. And once that's done cooking, we'll be dropped into the dotnet. There we go. And that looks nothing like the glob of paint that we so carefully crafted before. Well, to fix that, we need to go into the Flip Fluid Object node and find the Initial Data tab. Whoa, I'm just gonna zoom back in on our fluid. Now, under the Initial Data tab, we need to specify the SOP path to actually use the source null inside of our source. Bad naming perhaps, but there you go. Now we have the glob of paint like we expect. It is however looking a bit thin, so let's give it a few more particles by lowering the particle separation to about half. Cool. Let's play this and see what the simulation looks like so far. Okay, it falls with gravity and is probably the most boring simulation you've ever seen. Let's fix that by bringing in the velocity field that we set up. To do that, we're going to drop down a source volume node. And the first thing to set up here is the volume path. So let's point that to our vel node in our source. Right there, hit accept. And we also want to initialize flip and not smoke. So set it to source flip. Next, we need to tell it what to do with that volume, specifically the velocity field. Right now, it's doing nothing because it's set to none, and we want it to add velocity to our simulation. So let's set it to add. And the last thing to do is set up the SOP to DOP binding so it actually knows what the velocity field is called. So down in the velocity volume field, just type in vel on both sides. And there we go. Now we're ready to bring in our velocity into our simulation. So let's connect the source volume to the third input of the flip solver, which is where you plug in anything that will update the velocity. There we go. And before we hit play again, let's just go ahead and delete gravity, since that's not doing us any favors. But now when we hit play, we get some much more interesting looking simulations happening. We get some stringiness, we get some droplets following along, and it's all moving in a really cool splat-like manner. And if you want to tweak the look, all you have to do is go back to the source and change the mountain SOP to make the source look differently, because the normals will update and that will update the initial velocities. So you can keep tweaking that until you have a splash that looks the way you want it to. I'm quite happy with the look of this, so I'm not going to go back and change it. However, I don't need 240 frames of this. I'm going to need maybe 40, 50 frames. So let's set the timeline to 50 and let it simulate through. Okay, so the simulation's done and it's looking cool, but now we need to turn this into a mesh. So let's jump up and have a look at the nodes that the flip from object created. First, let's get rid of the fluid interior because no one cares about the inside. Now, let's dive into the source fluid node. There's a ton of stuff here and we need, well, pretty much none of it. Let's connect the import source node to the particle fluid surface node and just get rid of the rest. So the particle fluid surface node is going to actually mesh our particles that are coming in from the flip sim. And the cool thing is that we can actually control how it meshes and calculates the surface and all of that stuff. For example, if you want to make it a bit chunkier, you could increase the droplet size a bit, and that will make all of it look a bit more blobby. But for this, we're going to leave it as it is, and you can experiment with all of these settings on your own. However, we are going to play with the filtering because here you can find erode. And if you've done an alpha erosion on a sprite before, this is the same thing, but in 3D on the actual volume. So go ahead and enable the erosion and then right click and delete the channel, as by default it's hooked up to another channel, and we don't want that because we want to animate the erosion over time so we can make the mesh disappear in a natural looking way over the lifetime of the particle. So to do that, let's go to about halfway through the simulation and Alt mouse click on the attribute to set a key, and then we go to the end of the simulation to set another key. And for this key you want to find a value where the erosion has removed almost all of the mesh. Not completely gone because you're still going to pay for that frame, but as it's one frame from being gone, so to speak. So for this simulation, maybe 4 is a good value. So you're going to have to try that on your simulation and just see what looks natural as the simulation plays and the mesh erodes away. So when we click our way through the simulation, we can see that more and more parts of it are disappearing. So that's cool. The erosion is working. There are, however, some artifacts showing up in the mesh as the mesh is eroding through it. These square looking holes here and there. And that can be hard to get around, but sometimes you get a better result if you're using the spherical method instead of the average position method. However, even if that doesn't fix it, I wouldn't sweat about it because usually these things play so fast and they're so small in game that it's not gonna show up anyway. Now would probably be a good time to take a flip book just to see what this looks like when it's playing, especially now that the erosion is there. And that's done. So, as you can see, we have an interesting looking blob that dissolves in an omnidirectional splat and it disappears in a natural looking way. So I think we're doing pretty good so far. So before we move on, let's actually save the file so we don't lose anything. Give the file a good name as that will be used in the cache later. Let's go with Paintsplat. And let's actually go ahead and set that cache up so it's easier to work with in the next step. So drop in a file cache node. The only thing we need to change here is the end frame. Delete that channel because we want this to be 50. Like so, and hit save to disk. And with that, the simulation part of this mesh is done. Now we need to perform a few operations to prepare the mesh to be exported as a vertex animation texture. To stay organized, I'm going to rearrange all these nodes a bit and drop down a new node to do the remaining operations in. But first, let's rename the source fluid node to erode, so we know that's where the erosion setup takes place. Next, let's drop down a new geo node and call it prepare mesh. And let's drop inside. We're going to keep the file this time, and we're going to point that to the cache that we just saved out. And to make it just a bit less confusing, let's go up and actually disable the visibility on the erode node, so we only see the cache that we're reading back in. So the first thing I notice is that there's not much going on in the first few frames of the simulation. And we're still going to pay for that in the texture, so let's just cut them out. So let's drop down a time shift node. This allows us to just offset the whole simulation in time. So if you go up and click frame, you'll see that the expression is $F, so it will display whatever frame is currently active. So if we add 10 to that, it will remove the first 10 frames of our simulation. And that looks better, but this also gives us an error when we get above frame 40 because there's no more geometry. So let's cut our timeline down to be just between 1 and 40. Cool, so now we have all action and no filler. The next thing to tackle is the poly count. Right now it's way too many points. So you can see that it's quite dense, and if you have a look, we have 46,000 points at this frame. That's not gonna fly, so we're gonna have to poly reduce this. But before we can do that, we need to actually convert this mesh to polygons. So let's just drop down a convert. We can leave everything at default, it will generate the type of geometry we need. Now, let's drop down a poly reduce so we can get this down to some sane values. The amount of points in the mesh is directly going to affect the resolution of the vertex animation texture that gets generated by the end of this. And since those textures can't be compressed, it makes sense to keep it as low as possible. However, we don't want to go too low because then we will lose all of the definition. So it's a bit of a balancing act. The way I like to do it is to set the target to output a polygon count, because then you know how many polys you're getting at all times instead of a percentage of the original. And 1,000 is clearly not enough, as we can see here, so let's try something like 2,500 points. You could increase this a bit, but you don't gain that much more detail, so I think 2,500 is gonna work fine for this simulation. Obviously, yes, you are correct. This looks horrible and very harsh edges and everything, but we're going to fix that. So let's start by dropping down an attribute blur, and we'll use that to just smooth out all the positions, like that. But be careful though, so you don't lose all of those cool, interesting shapes. So if you feel that you lost a bit too much, you can adjust the step size to gain or get some of that back. Now, while that helped a bit, if we remove the wireframe and just look at the pure smooth shaded version of this, we can see that we really have some harsh edges that we need to take care of. So let's drop down a normal node and set that to points. And that will give us some smooth and soft normals all over the place. Nice. It's starting to look quite good for the low poly count that we're actually looking at. But there are a couple more things that we should do before we start exporting. The first one being cleaning up the mesh. As you can see, we have quite a few free-floating points, so let's drop in a clean node. And that should take care of most of them. You could go in and remove all of the geometry that has a surface smaller than a certain number, but I found that it's usually not worth it, and I just leave it as it is right now. So the final thing we do before we actually export this as a texture is just to drop down a null and call it VAT out, so we can find it from the ROP network later. And that's it. The mesh is now prepared to be exported, so we're going to jump over to ROP. But remember that when you have all of this set up, you could go back and just update the simulation and recache it just to get a completely different result. And that is a really powerful thing if you want more variations to the effects in the end. Now, let's jump over to the output context. And here we're going to drag in a vertex animation texture. You can find that on the Game Dev tool shelf. So drag and drop that in. And this has a few simple settings. The first is the method, and that will depend on what it is you're actually exporting. We're exporting a fluid sim, so we're going to have to set this to fluid because it has a changing topology. Then we need to point it to our VAT out node that we set up. Like so. And then we need to set a target poly count, and we already set this to 2500, so let's just match that. When you're setting the target texture size, you need to keep a couple of things in mind. Simplified, what you need to account for is the number of points on your mesh times the number of frames in your animation. Those will be the number of pixels you need on your texture. So for a 1K texture, you have 1 million pixels to play around with, plus minus some. So for a mesh that's 2500 points and only 40 frames of animation, we should be able to fit pretty much in a 512. So let's set it to that. And it's not the end of the world if it doesn't fit anyway, because it doesn't need to be a power of 2 or anything. You can leave the paths as they are, but you need to make sure that you normalize your data in 0 to 1 space, because that means you don't have to use a HDR texture, which saves you some memory. And you also want to pack normal into alpha, because they're doing some kind of black magic where they're calculating the normals based on the information that's just in the alpha channel. It's magic and awesome, so just leave it there. The color map we don't need to export since we're not doing explosions or lava or anything like that. The frame settings we can leave because that's reading the current frames. And the rest is just information that we'll use later. So we can go ahead and hit render. And once that's done, it's time to jump over to Unreal. First, let's bring in the results of that render. So find the folder where you outputted it all. And grab both the mesh and the texture. Just drag them into the content browser. Like so, and you can leave everything at default and hit import all. Close down that. Let's have a quick look at what it is we've actually created now. So let's first open up the position map, and it's gonna look super broken, but this is actually what it's supposed to look like. If we look at the RGB, we can see that these are just our positions. And if we have a look at the alpha, these are the values that will be used to calculate the normals for our mesh. So don't worry if it looks weird, it's supposed to be. The same thing goes for the mesh. If you open that up, you're going to see that it's just a mess of triangles. But don't worry about it. The shader will actually transform all of these into position for every single frame. So let's start building that material right now. So right click, hit new material and give it a good name. Something like m_VAT fluid base. And let's open that up. And now we can finally start building this mathematically quite challenging material. Or we grab the one that's included in the VAT ROP. So if you jump back over to Houdini and go to the ROP, and you can find the shader code section and open up the fluid version, select all and copy, and then jump back to Unreal, click somewhere in the material graph and hit Ctrl V. And you have a shader network. Let's move this to the side a bit so we can connect everything to the root. And to do that, you just paint by numbers. All of the end nodes are marked so you can see where it goes. This goes to base color. The next one goes to metallic, and so on. All the way until you get to the ones that say this goes to custom UV 0, because that one does not exist. So to do that, we need to add them. So select the root, and under material, open up this little arrow. And number of custom UVs, set that to 3, and you'll have the amount of UVs you need. So now you can just keep painting by numbers. That one, and there's one more down here. That goes to custom UV 2. Now, before the material is done, there's one more thing to do, and that is actually marked up here so you don't forget it. Make sure tangent space normals is off, and that is, again, under that little arrow, you just untick tangent space normal. And you're done. So go ahead and hit apply and close this down. But before you throw this onto your mesh, you need to set up a material instance. So right click the material and create material instance. Call that something fancy. Open it up. And let's have a look at these settings. So normal's data needs to stay on, pack normal needs to stay on, and we're not going to care about the color ramp, because these are just based on the settings we used when we rendered the vertex animation texture out, and we just need to make sure they match. Now, the bounding box min and max we actually do need to set up, and those values comes from the VAT ROP. So if you jump back to Houdini, you'll see that there's a section called Data for Real-Time Shader, and that's where we can grab the values. So let's go ahead and grab the max and copy that, jump back over and paste that in, jump over and grab the min, copy, and paste that in as well. And the next parameter is metallic, and you can do whatever you want with this, but I'm gonna leave it at 0. Then we need to fill in the number of frames in our simulation, and a bit of a heads up on this one, it's very easy to get the wrong number here. It's based on if you start on frame 1 or 0, so what I recommend is actually jumping back over to the ROP and check, because it will say the number of frames that it exported. So just use that number and you'll be golden. 39. Okay. Then the roughness min and max, you can set that to whatever you want, but I want it to be shiny, so I'm going to go between 0 and 0.1. And then for speed, we want this to play back at full speed, so let's set this to 1. Now, position map, this is the big one. We actually need to point this to our position map. And everything explodes. But we don't care about that, because no one's going to look. Hit save, and you can close down this instance. Now to check out your handiwork, let's drop in the mesh into the level, like so. Get a nice cloud of triangle-y chaos. That's cool. And let's plug our instance into the material slot, like that. And there you go. Unlimited splashy goodness. Well, at least as long as you're happy with it playing only as a static mesh and endlessly looping and without any real control. However, all of that can be fixed. First though, there is a small issue that needs to be taken care of. If you have a look at this frozen frame, you can see that it almost looks like the mesh has been shattered. And that's because it's not using full precision UVs. So let's enable that on the mesh right now. So open the mesh up, and under lot 0, there's a tab called Build Settings. And here you can tick the tick box that says Use Full Precision UVs. Hit save, close down the mesh. Yes, save it all, cool. And now the mesh is looking a lot healthier. And if getting a vertex animation into Unreal was your only goal of today, you've just succeeded. But we want to do a bit more than that. We want to create a particle system that emits these splashes when you hit something with your projectiles. So let's start building that particle system and do the material tweaks that are needed for that to actually work. So let's right click and create a new particle system, and let's call this something like FX Paintsplat. Open that one up. And the first thing we need to do is make sure that our particle system emits meshes. So let's set the type data to new mesh data and point the mesh to our splat. Like so. And then we need to make sure that we can override the material. So tick that box. And now we have our chaos mesh again. So in the required node, we can actually assign the material instance like that. And while that's thinking, let's drop the particle system into the level and remove the static mesh, since we don't need that anymore. Just drop that in there. And in case you missed it, we now have ginormous particles on our hands. That is because the initial size defaults to 25 in the particle system. So let's go and reduce that a bit. Let's set the start size to something sane like 1. So now we should be able to get a better view of what's going on. So we have the sequence playing back on our particles, but all the particles are playing it back at once. And they also don't seem to be moving upwards as our particles did before we assigned the mesh. Instead, all of the meshes seem to be centered around the particle emitter, and that's not really what we want. And that means our meshes are not accepting the particle transforms. And not only does that mean that the meshes won't follow the particles going upwards, it also means they won't accept scale over life or random rotations or anything like that. So let's have a look at what we can do to fix all of this. What it comes down to is that we need to alter the material. So let's start out by duplicating the material we created just so we have a backup in case we break everything. So let's call this _particle just so we know what it is. Let's open that up and dive in. Cool. So the first thing we want to tackle is the transforms, and that can be found over here where the actor position is read in and added to the absolute vertex positions. And we remove that and add in a particle position world space instead. And all of our transform problems are sorted, because now it will read in each individual particle's transform instead of just the origin of the whole system. With that taken care of, the next thing to tackle is to make sure that each individual particle can play back the sequence on its own, so it's not synced across all particles. And all of that is taken care of by a bit of math at the very left of the material. So by default, it's based on time, where it reads in time and splits it into individual frame chunks so we can progress one frame at a time. This doesn't really help us since we don't want it to be based on time at all. Instead, we want to control it over the particle's life, and we can do that by reading in a dynamic parameter instead. We can actually get rid of this whole first section up to the multiply and just replace all of that with a dynamic parameter, since we don't need the time to be a part of this at all. So drop that dynamic parameter in, and let's give it a cool name, something like frame selection. Doesn't sound like a superhero, but it's descriptive. Let's plug that into the ceiling node, like so. And now if we animate the frame select from 0 to the last frame of the particle life, that will cause our animation to progress the way we expect it to. So now we can go ahead and get rid of all of this time stuff that we don't need anymore. I'm gonna organize this up a bit. Okay, so that's taken care of. There's one more thing that we should do before we leave the material. And that's giving ourselves a bit of control of the color of the particle. So instead of the ramp, we don't really need all of this stuff. Let's drop in a particle color node and plug that into base color, like so. And now the material is ready to be used for particles, so let's hit apply and have a look at our material instance. And all we really need to do here is repoint our parent material to our new fluid particle version. And that's it. Hit save and we're done. So looking at the particle system again now, we can see that a few things have changed. Firstly, the meshes are now following the particles upwards, so that's cool. The second thing is that they are not actually animating through the sequence. And that's because we haven't yet added the dynamic parameter. So let's go ahead and do that right now. So right click and go parameters, dynamic, and as always, right click, hit refresh so it reads in the parameter names. Check the parameters. And number 0 should be our frame select, and it is. So our distribution should be set to be a curve. So let's set it to constant curve, and we need to add 2 points, one for the start and one for the end of the particle. We can leave the starting point at 0, 0, but the end we need to change so the in value is 1, so the end of the particle life, and the out value should be the final frame of our sequence, which would be 39. And that's looking all kinds of trippy, but it's actually doing what we want it to. It's playing through the sequence over the particle life for each particle. But to make this a bit more easy to read what's going on, let's add in a bit of random rotation to the system. So we're going to go ahead and right click, and on rotation we set init mesh rotation, and we can leave that at defaults. That's fine. Cool, so we're actually starting to get somewhere. That is starting to look quite interesting. We got some cool shapes going on. Now we can start building up our particle system. So let's start by giving it a bit of random size. Maybe between 0.1 and 0.6 would be enough. Yeah, that's gonna be cool. And now it's almost a bit too noisy, so you can't even see that it's moving upwards. So let's just get rid of the velocity for now. You can add that back in or some gravity later. That's all up to how you want the effect to look. But what I want from this is for it to look like a cool paint splat. So we need to add some cool color, because this is a very boring looking paint. So let's head over to color over life and give it something nice. And by nice, I mean hot pink. And for this, I'm actually gonna remove one of the points and just have a static color through the whole particle life. So let's get that color dialed in. Yeah, there we go. Next, we need to set up the loop. Since this is going to be a one-off splat on impact, we don't want it to endlessly loop. So let's go up to the required node and set the emitter loops to 1. So we'll only play through once. But we want it to spawn a bit quicker, so let's go to the spawn tab and set the constant rate to 0, and instead we use a burst. Let's open that, and let's burst 5 particles. That should be enough. And as you can see now, we kind of have a problem where the first frame of the sequence seems to be flashing on before the particle dies. And that's a bit of a precision problem. So what you can do to fix that is just lower the out value of your dynamic parameter by 1 frame, and that should all be sorted. And another cool thing that you can do now that you're controlling the sequence with a dynamic parameter is that you can give the parameter a bit of a curve. So maybe you want the blob to stay blobby for a bit longer and then go super fast through the end of the animation. You can totally do that by just adding in more points to the parameter. And I encourage you to play around with this parameter, because this is where you make the effect look really nice and snappy. But for now, I'm gonna leave it like this. Speaking of snappiness, this is way too slow, so let's have a look at the lifetime. 1 second is way too long for these particles to live, so let's reduce that to somewhere between 0.2 and 0.6. Now they're a lot more snappy and quick. And this you can also tweak depending on if you have gravity on them, so you want them to fall, but I want this to just splat quickly and be gone. And to that end, to make it look a bit more violent and quick, I'm gonna add one more emitter, and I'm gonna do that by duplicating the one we have. So let's just maximize this and right click, emitter duplicate. And this one I don't need as many of, so let's go to the spawn and maybe just use 2, 3, something like that. Let's go with 2. And then I'm going to use the initial size to just squish the mesh a bit so it becomes a thin burst of liquid. It's a bit of a hack. A better way would be to go back to Houdini and actually make a nice streaky fluid simulation and bring that in here like a blood squib or something. But I'm going to go with the squishiness because that's the quickest way of doing it. And then I also want to make it a bit faster, so I'm going to reduce the life to 0.3. So now we have a really nice and quick burst of liquid, and when you play both emitters, we get this nice 1-2 punch. And now the splash is starting to look pretty cool. Okay, it's looking okay. Let's go with that. You should probably spend a bit more time here just tweaking all of your curves and your lifetimes just to make it look snappy and the way you want it. But I'm going to move on and show the next step, and that's actually setting up the blueprint to trigger this effect whenever your projectile hits a surface. So if you're using the first person starter content like I am, let's go to the first person BP and then the blueprints folder. Let's open up the first person projectile blueprint. And in here we're mostly going to build our own stuff, but you can leave the notes that are there in case you want to go back. So the first thing we want to do in this blueprint when a projectile hit is detected is to actually spawn an emitter. So let's drop in a spawn emitter at location node. Like so, and we want to spawn this on hit, so let's bring the output from the event hit to our input. We want to specify that we want to spawn our Paintsplat, like so. And the location we can get from the get location node that's already in here, so let's just hijack that. And plug that into location. Cool. So now it will spawn a particle, but the projectile will keep on bouncing around, and that's not really what we want. So what we can do is that we can drop in a stop movement immediately node, just to make it just not bounce and stuff. So stop movement, and grab that, and that comes hooked up to the projectile already, so that's good. And the last thing we need to do right now is destroying the actors, so the projectile doesn't stay just frozen. And that node is already there, so just plug that in. And that's the base of our projectile done, so we can actually hit compile and go ahead and test this. And just hit play, and now when we shoot at things, we get splattiness. So that's pretty cool. It's doing what it should, but it is showing us a pretty crucial flaw in this whole visual. We don't have any decals, and that makes it feel kinda lame. Luckily, thanks to some of the new tools in the Simple Baker in Houdini, it's really easy to make awesome decal textures. So let's jump back to Houdini and make one right now. For organization's sake, I've started a new Houdini scene, but you could just as well do this in the previous one. The first couple of steps are going to be very similar to the previous setup, so I'm going to just rush through them. So I'm going to start by dropping in a sphere, and I'm going to give that a bit of extra geometry, and I'm going to distort it using a mountain sop. Again, the shape of this is going to be very indicative of the eventual splash, so you can always come back and tweak the values on the mountain top. So the process we're going to go through is that we're going to take this sphere, convert that into a flip fluid, and throw it onto a ground plane, and then we're just going to take a snapshot of the splash that ends up on the actual ground, and bake that out into an alpha texture and a normal texture. So to do that, we're going to raise this ball up so we can throw it down to the ground. We're going to select the sphere, we're going to go to particle fluids, and just like before, convert that into a flip fluid. Then we're also going to need a ground plane for this to collide with, so go to collisions and drop in a ground plane. This goes on forever in all directions, so we can just leave it there. And now we can jump into our DOP network and see that it's all hooked up and ready to go. We only need to do a couple of things in here. The first one is on our flip fluid object, we want to give it some downwards velocity. We do that in the initial data. And let's tick initialize velocity. And let's give it maybe -10 to start. Just so it looks like it hits the ground with some force. And if we play this now, it kind of looks interesting, but when it hits, it looks like it's sliding and going on forever. And that's not going to make an awesome splash for us. I mean, it doesn't look bad, but it could look better, and I want this to look a bit goopy and thick. So what we can do is jump over to the physical tab, and here we can give it a bit of bounce and also a bit of friction, so it will do more violent bouncing but slow down quicker. And that should give us an interesting splash look. Like that. You can keep trying different bounce and friction values as well as different velocities, and also go back and change the shape of the actual blob that you're throwing down. But I think this looks pretty good, so let's work with this. And let's first do some cleanup, get rid of the interior, hide visibility on the ground plane because we don't need to see that. We're only interested in the fluid. So let's jump into the fluid node. And again, we don't need most of this, so let's connect the imports to the fluid surface and visualize that. So that's what our splat looks like. So that's pretty cool. And we can delete the rest of the stuff because we're not going to use any of that. Now, what we are going to do now that we have a nice looking splat is that we're going to bake this onto a plane, and that will give us the textures that we can use as a decal. So you can scrub through and find a frame that you think looks cool, but still generic enough so it won't look bad when it's repeated a lot. And I think this one is going to work pretty well. So before I start baking, I'm just going to go ahead and save the file so I can use the hip variables. So let's just call this something descriptive like decal splat generator. That's cool. Hit accept. Okay, to start the baking process, first we need something to bake to. So let's drop down a grid. And let's try and make it match the shape of the splat so we don't waste any space on the texture. So maybe just scale it up a little bit. So, and offset it down. Yes, try to match it. Doesn't have to be perfect. Next, we'll drop in a simple baker. Like so. We'll plug a grid into the first input, which is the low, and a splat as the high on the right. So the simple baker has a few settings, but most of them are pretty straightforward. So the only things that we are going to want to bake out is actually the normal map and the opacity. So we can untick ambient occlusion and vertex color, and tick opacity, or the alpha. We're also going to want to lower our resolution to something like 512, but you're going to have to base this on how big it's going to be in game and how large a texture you can afford. And that's really all there is to it. So we can just go ahead and hit render, and it will spit out 2 textures for us. And once that's done, you can enable the simple baker to see a preview of the result. And if you get a mangled result like this, you can debug it by jumping over to the material tab and set your diffuse map to display your normals. And now you can clearly see that the normals are royally screwed. They have a large black patch in the middle that makes nobody happy. Well, that's because the splat was a bit too thick, so the rays didn't make it all the way through to actually bake the normals down. So what we can do to fix that is we can jump over to the Advanced tab, go down to Ray Bias, and increase this value, let's say by a factor of 10. And then we can just hit render again. And this time they came out looking silky smooth and just the way we want them. Well, almost. There are a couple of black spots still, and I should probably increase the ray bias a bit more, but it's such a small artifact that it's not going to make a difference, so I'm going to leave it for now. Other than normals, we can preview our alpha, just to see how that looks, and that looks exactly like the alpha I would want for this kind of decal. With the small caveat that this will only look good when it's static and it's not going to be removed. If you want to remove it, you should probably spend some time in making an erosion map out of this. But you can do that with a couple of actions in Photoshop. But for a static decal, this is perfect. And with that done, let's jump back over to Unreal. And as always, the first thing to do is to import the textures. So find where you saved them, grab both the alpha and the normal, and drag them into the content browser. It's imported as a normal map, which is exactly what we want. Okay, so now we need to start building a material for our decal. So let's create a new material. And let's call it something like splat decal. And let's open that up. All right, so the first thing we need is both our textures. So let's go back to the content browser, grab both the alpha and the normal, like so, and just drag it into the material, and it will create a couple of texture samples for us. Maximize that again. And before we plug this in, there are a couple of settings we need to change on the root to make this actually behave like a decal. So let's select the root, and let's change the material domain to deferred decal. Like so, we're going to set the blend mode to translucent. And finally, we're going to set the decal blend mode to debuffer, translucent, color, normal, roughness. Well, it's the top one with all of the features. Debuffer decals are a special kind of decal that actually look good compared to the normal ones. And to be able to use them, you need to check your settings. So jump over to your project settings. And in here, you're going to search for debuffer. Make sure that debuffer decals is ticked. And if it's not ticked, tick it and restart the editor right now. If for some reason you're not able to use debuffer decals, you can use the normal decal blend modes, but it won't look any good really. Now, back in the material, we can start plugging things in. So let's start by plugging our alpha into the opacity slot and the normal into the normal. We're going to need a color to match the hot pink of the particle system. So let's drop in vector 3 and plug that into the base color. And let's set the color of the vector to a nice pink. Like that. That's the stuff. And once that builds, we can see that we have some kind of a splat going on our preview sphere. It's nice and thick, but it's way too rough. So let's fix that by dropping in a constant and plugging it into roughness. And let's just leave it at 0 so it's nice and shiny and delicious looking. Don't need paint. And that's looking nice and shiny and goopy. And this is all we need for a material, as it's going to be a static decal. So let's hit apply and let's check it out in the level. And to do that, all we have to do is grab the material and drag it into the level. And there we go. Oh, look at that. The alpha and the normal map are working really nicely together to actually make this look almost like it has a bit of depth. And that's really cool. But static decals are boring, so let's spawn this one when the projectile hits the surface. And to do that, we need to jump back into the projectile blueprint we worked in before and do a few tweaks. First, we need to actually spawn the decal. So let's drop in a spawn decal node. And there are 2 of these. One just spawns the decal on location, and one spawns it attached. And I prefer to use the attached one because if you have physics going on in your level, you want the decal to actually stay attached to whatever it is it hits. So let's drop down a spawn decal attached. And let's plug that in. Then let's point it to our actual decal. So splat decal, cool. Then we need a position. And we can use the same we used for our particle system. So let's just go down and find the get actor location node and plug that into location. And then we need to change our location type because the default is keep relative offset. And that will actually scale the decal based on the size of the object it hits. And that can give you some really weird and unpredictable results. And it really is enough to keep the position. So let's set it to keep world position. Since decals are actually projected onto the surface they're shown up on, you can get a streaky mess if you're seeing it from the wrong angle. So, to ensure that we see the texture on the object that we hit with our projectile, we need to build a rotation. And we can do that by grabbing the hit normal from the event. And then we feed that into a make rotation from X, because that's the axis it projects along. So let's drop that down from X. Feed in the hit normal, and that will give us the rotation we need, and we can plug that straight into rotation. Cool. Next, we need to set up our size, and this can be whatever you want, but I'm going to make this one fairly large because it's a large splat. So let's set the Y and Z to something like 150. The x-axis is a bit different since that's the axis it's projecting along, so we need this to be a thin sliver to make sure that we don't get a whole bunch of streakiness going on if it's intersects with the wall. But we also need to make an adjustment to compensate for the fact that the hit normal is pointing into the wall, while the decal needs to be projected in the opposite direction. You could flip the hit normal before making the rotation, but I find it easier to just give the decal a negative size in x. So let's make it -30. And before we can go ahead and test this, there's only one more thing to do, and that's telling the decal what component to attach to. And that's the very strangely named other comp on the event. So let's connect those up. And now we can hit compile and actually test this. So let's hit play. And there we go. We got decal spawning. Ah, there we go. It's looking cool. However, there is a problem. If you shoot a bunch of these next to each other, we can see that they're all rotated the same, and that's not very cool. And they're also a bit small, so let's make them a bit bigger. Maybe 200 is enough. Cool, so let's add some random rotation, and we can do that with an add relative rotation. So we can drop that in. And it's going to default to a sphere, but we don't care about that. So just get rid of that thing, go away, and plug in our decal instead. We're also going to plug in our input. There we go. And now we need to build another rotator. So let's drop in a make rotator, like so. And we can plug that into the rotation. And we're only interested in the X rotation, or the roll, because the other axes are already taken care of. So what we need to do is that we need to drop in a random float in range, so we can specify our range of how much randomness can we feed into the X. And this range should be between 0 and 360 degrees, so it can be rotated in any direction. And with that plugged in, it's all done. Let's hit compile and play, and let's see what we've got. Go. They are now randomly rotated, and we can go ahead and paint the whole level. Don't paint the whole level, because that's going to be super expensive if you don't start removing these decals. If you want to make a painting game, look into render targets. But this is going to work perfectly if you just want a gun that shoots paint every now and then. It looks pretty sweet. So the next step for this would be to use the lifespan on the spawn decal node to actually drive a fade of these decals so they don't stay around forever. And then, of course, you can start fining and improving the effect and making more decals so you can have some more variation when stuff is happening. But I'll leave all of that up to you. You now have the tools to make something really, really cool. And I hope that you've learned something. And as always, thanks for watching.